All right, welcome to my presentation, which is going to focus on peatlands or mares from Tasmania, and basically looking at coastal peatlands to upland peatlands. Just to introduce myself, I'm Professor Patrick Moss from the School of Earth and Environmental Sciences, the University of Queensland. This is a collaborative project between UQ, the University of York, Forest Practices Authority Tasmania, and Department of Primary Industries, Parks, Water and Environment, the Tasmanian government. There's also a number of co-authors associated with this research, including Roland Gerrels and Sophie Williams at the University of York, Peter McIntosh and Adrian Slee at Forest Practices Authority Tasmania, and Jason Bradbury at Department of Primary Industries, Parks and Water and Environment in Tasmania. So basically what I'm going to focus on today is looking at three studies. The first study is a short record from Lutregala Marsh on Bruny Island in the south east of the island. Then we'll move up to an upland site, Yellow Marsh at Surrey Hills in northern Tasmania, and then look at some coastal mares in the Port Davey region in the Tasmanian Wilderness World Heritage Area. Now, again, the timeframes that we're going to be focusing on is basically from a few hundred years in the case of Lutregala Marsh to 10,000 years with the Yellow Marsh, and still to be determined with the Port Davey research. All right, so Lutregala Marsh is located at Simpsons Bay in Bruny Island. Now, again, we've extracted a very short core here, and you see basically the peat, the salt marsh peat here at around about 20 centimetres. Beneath that is sort of subtidal muds. So in many respects, we're observing a prograding system here. Lutregala means fine day in the traditional language of the Indigenous groups that occupied this region. And it's a 42 area of 42 hectares of salt marsh and coastal forest. It's actually managed by the Tasmanian Land Conservancy, so it's basically purchased, particularly for bird conservation, about 20 years or thereabout, and they're managing it at the moment. So prior to this, it was used for grazing. There's some evidence of drainage of the system as well, but generally looks relatively undisturbed. In terms of the broader Bruny Island environment, we have evidence of Indigenous occupation for the last 6,000 years, and European settlement occurred around about 1880 AD. All right, so this shows the location of the marsh. So again, you can see some of those features, drainage features there. There's a creek system coming through, and we focused our core collection and analysis through here. Now, the sediments were actually collected to examine sea level change over the last 200 years and using foraminifera basically to develop a transfer function to look at how sea level has changed here and part of a broader project with the University of York. And Sophie Williams is a PhD student working on that aspect. But one of the really interesting aspects of this site is that it provides some insight into landscape change at Bruny Island, particularly that transition from Indigenous occupation to European colonisation. So I'm going to be focusing on that for the talk. So this is a transect across the site, and that's a sediment core. Again, another image of the sediment core that was collected as well. So you can see the peat in that sort of top 20 centimetres or thereabouts. All right, so we've produced a pollen diagram here, which goes back around about 400 years. We have evidence of European arrival here in the 1820s, which is reflected by the presence of exotic taxa, particularly exotic daisy. And then we see a little bit of evidence of deforestation here with this peak, and a little bit of decline in arboreal taxa there as well. Probably one of the most interesting aspects of the record is the transition in burning. So we see a clear and marked decline associated with European sediment coming here and suggesting that this landscape was managed by Indigenous fire management. And we see still relatively high grass values and eucalypt values here. So probably reflecting an open landscape, probably to facilitate hunting of game and so on. There's some other interesting changes you can see here, where we see this decline in Restinaceae, an increase in chenopod or Amaranthaceae, which reflects the development of that salt marsh peat coming through, and pretty much coincides with European settlement. I think it's independent of that fact and probably reflecting broader um, sea level changes that are occurring at that time period as well. But again, the key take-home messages for that are essentially that drop-off in charcoal and basically the slightly more open landscape, but not significantly different from what we see today. We've also utilized XRF data, so high-resolution XRF data, which is shown here. And again, what we see there is evidence of that subtidal environment, so high amounts of iron, silica, aluminium, and so on. It sort of declines up until the top part of the record. And interesting enough, we see some evidence of zinc there as well, which is probably an indication of the zinc refinery occurring in nearby Hobart and evidence of European impact. We also see some interesting peaks in iron, which might be reflecting increased soil erosion associated with European colonisation. So to summarise that, we see salt marsh progradation or sea level change in salt life progradation over the last 500 years, particularly over the last 200 years. And it's similar to another site we've worked on the east coast at Little Swan Port, close to Freycinet Peninsula. XRF data observes changes in geochemistry that reflects these alterations. Clear evidence of European sediment, both from the pollen and itrax data. So around 12 centimetres is where we see pollen evidence of those exotic taxa. We also see evidence of smelting activities from Hobart, as I mentioned. So for instance, zinc smelting started in the 1920s, and there's a clear peak in zinc occurring there. We also observed that in terms of the pollen record, in terms of deforestation. Now, the next site I want to move on to is Yellow Marsh in Surrey Hills. Now, this is based on a couple of research projects, a couple of honours students, so Emma Watson and Judith Vink in particular, have focused on this, and we're actually in the middle of submitting, it's currently under review, a paper focusing on the sort of peatland history of the site itself from Yellow Marsh. So Yellow Marsh is situated in northern Tasmania, not too far from Wynyard. Very distinctive feature in that landscape. It's within the Surrey Hills plantation, so it's currently used for forestry, but also really important in terms of providing evidence of environmental change associated with Indigenous or First Nations people. So it's a key location for the fire stick farming theory that was developed by Rhys Jones in 1969, and the Greatest Estate on Earth book that Bill Gammage released in 2011. So basically it's the argument that these landscapes were a cultural landscape created by Indigenous burning and fire management regimes. Essentially, it should be climatically rainforest, but is actually a mix of rainforest, buttongrass moorland, and eucalypt forest, and that landscape is very much an artifact of Indigenous fire management. Michael Sean Fletcher published a paper in 2021 focusing on this, looking at sort of shorter term records, similar to the Lutregala Marsh record, so focusing on the last 200 to 300 years, and has observed or indicated significant landscape change since European settlement based on that transition in fire management. So Yellow Marsh itself is a 24 hectare mixed sphagnum, buttongrass, heath mire. We extracted 2 sediment records in 2010 and 2017, 3 metres of sediment, with about the first 2 to 2.4 metres being peat, essentially. So we're interested to sort of look at the history of when that peatland developed, and also focusing on environmental change, and maybe sort of seeing if we can see evidence of Indigenous fire management there as well. So this is the pollen record, which you can see here. It goes back 10,000 years, so we have peatland development for basically about 10,000 years, but there's some really interesting changes occurring there. So what we see towards the sort of first area here, probably from about 10,000 to 7,500 years ago, is dominance of rainforest, and probably rainforest recolonizing the area at the end of the last glacial period, in particular a lot of Monotoco, which is often a very sort of early rainforest recovery species in Tasmania. But then there's a really interesting transition where that monotoka declines and we have an increase in heath, ericaceae, occurring. And it also appears to be associated with increased burning, so particularly in both the micro charcoal, so charcoal up lower than 125 microns, and macro charcoal, which is bigger fragments of charcoal above 125 microns, reflecting local and regional burning essentially. And we basically suggest that that is reflecting Indigenous fire management, and resulting in that change and creating that more open landscape. We also see a change in dominant tree taxa, so from Phyllocladus to Nothofagus or southern beech there as well. But this dramatic increase in heath is probably the key factor there. The other change occurs about 3,500 years ago, and we think again that's the result of an increase in El Niño Southern Oscillation intensification, which is observed across the Pacific Basin region, and also probably reflecting a change in Indigenous fire management response to that. So we see eucalyptus forest probably indicating things drying out a little bit more, decline in rainforest, but Indigenous people responding to that in terms of their fire management. And then the top section is basically the European phase, where we see an increase in heath again, increase in grass, and a dramatic decline in regional burning there as well, and evidence of exotic taxa and so on. And that's the plantation phase. So to summarize that, we see a shift from lake to mire around about 10,000 years ago, so the peatland developing. Indigenous fire management has had a major influence on the Surrey Hills landscape, so it seems to be confirming the fire stick farming theory of Jones, particularly after 7,500 years. So there is a complex relationship probably between thresholds and also climate change, and people also adapting to climate change as well. So particularly at 3,500 years ago. So we find clear support that this was a cultural landscape at the time of European colonisation, and as a result of that process, we're actually seeing vegetation thickening occurring. So basically, shrubs are invading the open grassland areas and taking over with the release of that Indigenous fire management as well. All right, last couple of minutes, I just want to focus on some ongoing or new research that we're doing in Port Davey, Melaleuca region of southwestern Tasmania. This is in with the Tasmanian Wilderness World Heritage, and we're essentially looking at 3 sites. So these cores were collected earlier in the year, so we're fortunate enough to do some field work. So we're interested in a couple of things, in particular these very distinctive patterns in these intertidal areas. So we're interested in sort of seeing what's causing those and creating those features. So that's at Hannett Inlet. One of our other sites sort of sees those patternings there. This is actually a drone footage of the coring activity that's occurring there. We got I think about 1.25 metre core from this site. But again, you see sort of that very distinctive patterning there. So we're particularly interested in sort of focusing on how that's occurring. We're also looking at another site, Old Creek, which is another salt marsh creek. So maybe seeing the influences of sea level. Again, we've got some very detailed vegetation maps here, so it's a mix of predominantly open heathland, button grass moorland with some rainforest and eucalypt forest present there as well. So longer term changes there as well. So far we've undertaken XRF analysis of one record, Puffin Creek, which is the longest record, about 280 centimetres. Some interesting changes occurring there, so particularly change in silica, which might be reflecting increased erosional events, and calcium and other changes there, which might be reflecting changes in increased coastal or marine incursions and things like that. But again, this is very much hot off the press, so we're still working through the interpretations of that. All right, so in summary for the Port Davey estuarine mires, we're examining the age formation processes associated with these 3 systems, and in particular the role of sea level change and coastal processes in creating the patterning that I mentioned before. In addition, the pollen charcoal records providing evidence of vegetation and fire history, and in particular sort of investigating the relative role of anthropogenic and natural factors. And this will provide important information for the future management of these systems and the broader World Heritage area as well. So in conclusion, we've looked at 3 sites across Tasmania, so from Lotregala Marsh, Yellow Marsh and Surrey Hills and these regions, and hopefully provide some interesting insight into fire, vegetation history and mire development.